When running Romex wiring, especially in residential settings, it's important to consider the physical protection of the cable. The question addresses a specific scenario: wall layout, door, window, corner. The distance from the door to the corner is 5 feet. In this scenario, the outlet must be on that wall. The only reasonable place to mount the box is on the stud, which is part of the window frame. The concern is how to run the Romex to avoid future damage, particularly from drilling. The suggested practice is to avoid running Romex directly up a stud that's part of the window framing. People often drill into these studs to install drapery hardware or other fixtures, increasing the risk of hitting the wire. A safer approach involves several steps. Firstly, staple the wire a short distance above the electrical box, approximately 1 foot. Secondly, traverse diagonally from that stud to the adjacent stud. Thirdly, secure the wire with staples. Finally, run the wire straight up the second stud. Penetrate the ceiling plate and continue the wiring run. This method provides a degree of protection against accidental drilling. The National Electrical Code, or NEC, provides guidelines for protecting cables. Section 300.4 D addresses protection against physical damage. It states that cables and raceways installed parallel to framing members must be protected where subject to physical damage. In the scenario presented, the described wiring technique indirectly addresses this concern by moving the cable away from the immediate drilling zone around the window frame. NEC Section 300.4 A covers bored holes through framing members. It states that where cables or raceways are installed through holes bored in framing members, the edge of the hole shall be not less than 1.25 inches from the nearest edge of the framing member. If this distance cannot be maintained, the cable or raceway must be protected by a seal plate or bushing. While the question specifically states this is not about the 1.25 inch requirement, it's important to be aware of this code when running wires through studs. Although the question specifically addresses avoiding direct runs up window frame studs, it's a good opportunity to consider general best practices for Romex installation. Here are several key considerations. Firstly, always to energize the circuit before working on any electrical wiring. This is a fundamental safety precaution. Secondly, use appropriate cable staples to secure the Romex. The staple should be properly sized for the cable and should not damage the cable sheathing. Thirdly, avoid overstapling the cable, which can compress the conductors and potentially damage the insulation. Fourthly, when running Romex through bored holes, ensure the holes are smooth and free of sharp edges that could damage the cable. Fifthly, use cable bushings or grommets where the Romex passes through metal studs or enclosures to protect the cable from abrasion. Sixthly, maintain proper spacing between the Romex and other objects, such as pipes or heating ducts. Seventhly, follow all applicable local and national electrical codes. Always check with your local building department for any specific requirements in your area. Eighthly, when working in damp or wet locations, use appropriate moisture-resistant cable and fittings. Ninthly, properly terminate all connections at the electrical boxes and devices. Ensure that all screws are tightened securely and that no bare conductors are exposed. Tenthly, after completing the wiring, test the circuit to verify that it is working correctly and that there are no shorts or ground faults. When working with Romex, it's also crucial to understand the different types of cable available. NMB cable is the most common type of Romex used in residential wiring. It is suitable for dry locations only. USB cable is designed for direct burial and can be used in wet or damp locations. Consider the ampacity of the Romex. The ampacity of a conductor is its current carrying capacity expressed in amps. The appropriate size of Romex must be used for the circuit it will serve. Table 310.15 B16 in the NEC provides ampacity ratings for different sizes of conductors. For example, 14 American wire gauge (AUG) copper wire typically has an ampacity of 15 amps, 12 AWG copper wire has an ampacity of 20 amps, and 10 AWG copper wire has an ampacity of 30 amps. These values are for typical conditions, and deterring factors may apply in certain situations, such as when multiple conductors are bundled together or when the ambient temperature is high. Overcurrent protection is another crucial aspect of electrical safety. Circuit breakers and fuses are designed to protect wiring from overloads and short circuits. The overcurrent protection device must be properly sized for the circuit and the wiring. For example, a 15-amp circuit requires a 15-amp circuit breaker or fuse, a 20-amp circuit requires a 20-amp circuit breaker or fuse, and so on. Never use an overcurrent protection device that is larger than the ampacity of the wiring. This could result in overheating and potentially cause a fire. Grounding is essential for electrical safety. A grounding system provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock. All electrical boxes, devices, and appliances must be properly grounded. The grounding conductor is typically a bare or green insulated wire that is connected to the grounding system. Arc fault circuit interrupters, or RFCs, are devices that protect against arc faults, which are dangerous electrical conditions that can cause fires. RFCs are required in many areas of the home, such as bedrooms and living rooms. Ground fault circuit interrupters, or GFCIs, are devices that protect against ground faults, which are electrical conditions that can cause electrical shock. GFCIs are required in wet locations, such as bathrooms and kitchens. When working with Romex, it's essential to use proper wiring techniques. This includes making secure connections, avoiding sharp bends in the wire, and properly supporting the cable. Poor wiring techniques can lead to electrical problems and safety hazards. Always use a voltage tester to verify that the circuit is de-energized before working on any electrical wiring. This is a crucial safety precaution. When making connections, use wire connectors that are appropriate for the size and type of wire. Ensure that the connections are tight and secure. Avoid using electrical tape as the sole means of insulation. Electrical tape can dry out and become brittle over time, leading to loose connections and potential hazards. When running Romex through walls or ceilings, avoid damaging the cable. Use a cable stapler or other appropriate tools to secure the cable without damaging the sheathing. Avoid running Romex in areas where it could be exposed to physical damage, such as in attics or crawl spaces. In these areas, it's best to use conduit or other protective measures. When working with Romex, always follow the manufacturer's instructions. The manufacturer's instructions provide important information about the proper installation and use of the cable. Consider the environment in which the Romex will be installed. If the Romex will be exposed to moisture, chemicals, or other harsh conditions, use a cable that is specifically designed for those conditions. When working with Romex, it's also essential to have the proper tools. This includes a wire stripper, a cable cutter, a screwdriver, a voltage tester, and a cable stapler. Using the right tools will make the job easier and safer. When in doubt, consult with a qualified electrician. Electrical work can be dangerous, and it's always best to leave it to the professionals if you're not comfortable doing it yourself. Remember to obtain the necessary permits before starting any electrical work. Permits ensure that the work is done in compliance with local codes and regulations. After completing the electrical work, have it inspected by a qualified inspector. An inspection will ensure that the work was done correctly and that it meets all applicable codes and regulations. When running Romex, consider the aesthetics of the installation. Try to run the cable in a way that is neat and unobtrusive. Avoid running the cable across walls or ceilings where it will be visible. When running Romex through finished areas, use cable concealers or other methods to hide the cable. Consider the future needs of the electrical system. When running Romex, plan for future expansion or changes. Run extra cable or install empty conduit to allow for future wiring. Keep a record of all electrical work that is performed. This record should include the date of the work, the type of work performed, and the materials used. This record will be helpful for future maintenance or repairs.